back to another video. It's summertime, and in summer for some reason I like to work with the 80 Tiny. They are very relaxing. So, and as you can see here, we have Arduino Uno just working as a programming device, and you may recognize this program that I have in the 80 Tiny. It's the Switchless Kernal Switcher for the C64, and this time I have two of them. In this project I want to transfer a setting on the output over to the other one. Now the thing here is that an idea I got from a viewer on my channel. I was fixing a bug this summer, and Newcam contacted me, and he said that a 15-bit did never turn on when it was in a 8 kernel mode. I fixed that, so that's okay. He made a cool modification to his C64. There's no ugly switch here like you see on some drives. They have like a big knob. It has a tiny hole here, and he's using the C64, the Switchless Kernal Switcher, inside the drive. I have never tried this, so thank you very much Newcam for doing this and telling me about the bug. And also I vented the idea of connecting to the Switchless Kernal Switcher in both the C64 and the floppy drive together, and he did some research for me. And we were talking about the reset line. He said there was some difference between the models of the motherboard, but that's fine. I just want to try this. So basically what I want to try to do is maybe use the reset line. You can see how the switcher works. You can hold the restore key, and then when you click the restore key on the C64, you can go through all the rooms, and then there you go, there's a reset issued after you release the button. So I think I will try to put a serial communication from this one over to this one. I have only 6 IOs on this board, so I think I will use the reset line as both to listen and to send. And for this we will be using the digital discovery. Yeah, so we use that as a digital oscilloscope, sort of. And then we will debug the transfer and the communication. So we're going to fire up waveforms. Then we have logic here. We just add a signal or a UART. Because a UART you can decode, it's connected to DIN0, the reset pin, or the int reset of the Commodore 64. I like to set up manual baud rate because it doesn't find it so easily, and then we trigger on folding edges. So the first thing we do is just a single trigger. However, I have learned that it's good to have these settings like this. So let's try it. Let's just go to, yeah, let's just see what happens. There you go, you can see it triggered. You saw this one flash. Well, that's this line here, you can see, and it's about, let's see, it's about 300 milliseconds. And over here nothing special happens, but at the very beginning of this reset pulse we have data. So here you can see a special keyword DE. I use that in the firmware. I have a check for DE, and if there's a DE it waits a millisecond and checks again. If it doesn't find it, it will just go through the buffer, or the serial buffer. But if it does have more data, it will put it in the room and set the LEDs outside. So yeah, so that's what's going on here. We have kernel number 2, or bank number 2. So let's try it again. Hit single. I keep forgetting that, so let's set it to bank 7. There, let's see what happens. Oh, there it goes. Bank 7. So I'm hoping that even though we have many reset pulses going on here, the C64 or the floppy drive doesn't mind, because it does get a proper reset after this, so which lasts for 300 milliseconds. So let's have a quick look at what I did to the firmware. I have modified the Neo software serial firmware. So what did I do to make this work? I copied these files from the Arduino library. So let's say manage libraries. There you go. So this one I have already installed it, so I installed it. But I'm not interested in the installed version. So what I did is I poked around a little. I can search for it with a grep, find and grep, like this. And there you go. There's the original files that I downloaded. So I copied those. And why do I have to change it? You call the constructor and you set input and output pins. I think I can double check here quickly. Yeah, receive pin and transmit pin. Right. It's not supposed to work when you use the same pin on both, but that's what I'm doing. What did I have to change? Well, first of all, to make this to be able to use this software inside of Sketch, I had to copy these two files into the folder, and then it comes up here automatically when you open Arduino. The second thing I had to do was to I had to change from bracket to quotes, double quotes, and also inside the library itself, or else it won't compile. The constructor eventually calls set baud rate and listen. So in the listen, the TX pin was set to output, but since they are the same, I'm not supposed to do that because we're supposed to listen, not to write to it, right? So that was happening on my board here. I couldn't get any serial data out because when I was sending, the other one was driving the line at the same time. So that's why I'm checking. So if they are equal, it will not set it as an output. Alright, let's go to the right part, because now we know that the right pin is not an output, so you have to do something about that when you're writing. If TX pin equals RX pin, that's the case we have now, then we want to set it as an output. But we don't want to set it as an output if they are different, because that was not original how it was working. And at the end, when it's done writing all these bits, we will set it back to an input so we can listen again. So yeah, so here you start the thing, and then in the setup, and the next thing I do when I get to a reset, state reset, that means that you have selected a room or bank. Then the state machine goes into the reset mode and it sets the LEDs. It sets where it's going to go next. It's going back to idle. However, I want to write this to the other microcontroller. So, because it's listening now, we don't want to listen anymore. So that's why we call ignore. So we don't fill up our buffer while we are sending something. And then we pull the line low. This is pulling the line low for 300 milliseconds. Then we go back to listen. So that's all I had to do. That's everything. So really cool. Took me a little bit of a while to explain it, but yeah. I will try put it in a drive and see if we can actually do this. I have the Switchless Kernal Switcher here. I made another one. And I took out the ATtiny and put it in here. So now I'm just going to test it, see if it's working before I put it in a drive. So let's hook up power. There you go. Let's set it to red, which is 4, I think. There you go. So that's working. Let's set it to 7, which is white. So I have connected a wire to ground here, so we can just apply ground to restore. Let's put it to blue, see what happens. Yep. So this is working. So now we can try it in the drive. And I will also put this one in a Commodore 64. So I have the same program in both of them. So somehow we're going to have Jiffydos automatically selected both in the drive and the C64. Okay, I have the two 1541 drives here. And I have some good news because the 1541C is a bit different. And it has a 16K room where you have to like have a 28-pin adapter and stuff. But the other one you have a 24-pin to 28-pin adapter. You can see the nice little fan assembly we have here, which is a 3D printed bracket and everything. So I can link in the description the video about that. Now you can see that this one has 2 rooms and this one has 1 room. So this one is 16K and these are 2 8K. This is a 1541C board. That means that it has different firmware. This one has a 1541 firmware. You have 2 versions of this. You have one that goes all the way over here. So this one is a kind of a middle length board. So anyway, that makes it much easier for us. So let's just get in closer so I can show you. You can see the 2 rooms. I need to figure out which of them I have to swap out. And here you have the other guy on the 1541C, which has a hybrid PCB there. Yeah. So all of this analog stuff is put into a sort of epoxy thing with SMD parts, I think. So, and this is the first board. This is the first drive I bought. I bought it used. It was broken, so I got it from. I got it for 100 Norwegian kroners. So it was a real bargain. Actually, the C64 wasn't so expensive back in 2015. And I only had to replace this one. So it was a bit fault finding. I'll also link in that video in the description. This one came with the C64 bread bin that I bought. And it was working perfectly. I only greased up the rails in here on this drive assembly. Reed head assembly. So yeah, this is very cool. So you can see here, this is 1984. And you can see the SC there, 250442. This is made by, I will also link this video in the description. I don't think he is active anymore. But the nice thing about this bracket thing is that it fits inside this heatsink for the power regulators. Now it's a very tight fit because if you look here, you can see there's not there's like this much room or something before it hits the snag. So that's another problem I'm going to have here. Will the room be too high? Well, there's more room here than it's here, maybe. Now that we got that out of the way, let's have a look at the room creation readme text there. And for the 1541, we have 2 rooms. So this is the one we are going to replace with our switcher. And we put this image in the first, or the 0 bank, and the first bank we will have the Jiffydos. So yeah, so that's this guy then, this one over here. Yeah. As per usual, I have a little bit trouble desoldering here, so what I'd like to do is to just feel, see that it's moving, then it's free. If not, I'll try to just bend them a little bit. This one's free, 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 not so free maybe. This is free, free. Oh, this wasn't free actually. Not this one either. This one doesn't look free, but we'll try just gently. there it goes. Yeah, so you have, if you do this, bang, you will rip up pads. But if it doesn't give away at once, you can try it a little bit, but too much, it will take pads with it. So there you go. Yeah, there you see the little solder tag thingy. There. It was hooking on that. Hooking. Anyway, so there you go. You can see it's fine. Just clean it up. It's good to go. The cool thing about this camera is that I can get up close, so you can see it's looks okay, nothing's broken. And also this side looks fine. Let's see. What else? I can't get my hand in there. Yeah. This. Well, actually, I think I can just bend it inside here. Why not? Okay, let's see. You see, it's already quite high. So, well, it's actually quite hard fit. So, there it goes. I hope everything is in place now. Yeah, let's go. Yeah, looks good. Just put some solder in there. We're good. And then yeah, should be good for another 30 years, don't you think? Let's see. See if we can just bending and twisting we have here. I don't want to bend them. So yeah, that was sitting quite good. So just get out this glue stuff. There you go. Yeah. Then we'll just insert a room here, and hopefully it's not too high. Right, so had a little problem with space there. Also, work called me, said I had to come back to work for a day or two, so that means even less space on the table here. But we have the C64 Switchless Kernal Switcher in here, and I even made a cable for it. As you can see, it runs in over there. That's nice. We don't have a room yet, so we'll burn that. And over here we have the trusty bread bin, and it has an old switcher, so I will have to switch that out. Yeah, because I can't use this one because it has an older microcontrollers, 12F629. As you may know, in 2019 I switched to ATtiny 85. So let's turn it on. I have burned an EEPROM. So let's give it a go. The drive stops, and that's a good sign, or else if it just continues to run, something is wrong with the CPU usually. Now a problem I have is that the kernel switcher is in 8 kernel mode, so you have to bring it down to 4. That means we have to ground, so be a bit hard to film. So what I basically need to do is to put something on ground and then hit restore there while I power it up, so it goes into setup mode. It's not the greatest camera angle, but we'll have to do. So I'm not sure how I'm going to do this actually. Alright, I didn't show you, but I've connected ground there, behind there, and the capacitor, the big capacitor down there. I'm just going to hit restore here. You can follow the LED here, so let's see. So it just resets correctly. Now it doesn't go back from reset actually. I don't know why that is. But anyway, now we're gonna I think what happens now is that I have it in 8 kernel mode. I have only burned 4 of 8 kernels. So what we need to do now is we need to hold restore here carefully. This is scary. So I think I'll make firmwares that has all of these, so you just can burn the correct one instead of doing switching like that. So now it's in setup mode. You can see 2 long flashes. Let's click it. Short. So short means short board. And long, short, long. No, I think it's long, short. There you go. Long, short. That means long board and only 4. And then you just hold it again. I think careful until it goes back to red. Okay. Now it stops. Okay, let's try red. No. Try green. This is working. So it seems to be something wrong when I select anything else than green. No, blue is working too. And cyan. But red doesn't work for some reason. Right guys, I've connected up everything. You can see the serial cable. So let's just power it up. You can hear the fan, maybe. And the motorcycle. So let's try it. Okay, this one went to blue. And we are in exhaust. Let's try something else here. Oh, it's going in setup mode. Yeah, because I don't have a proper keyboard. Let's go to red. Yeah, it goes to red, but it doesn't stop. So I have to figure out why that is. I was about to pack down for the evening, but then I realized that 4 kernel mode is actually using another chip. And it's using the red LED, but the red LED is actually A15 on the ROM. So when the red is lit, it's actually a kernel outside here. So that's why it's not working. So at over 8000 hex, there's nothing. So that's why it's not working. So I will just add that quickly. Just have to release this chip first, and we'll program it. So just for the sake of the video, I will show you that I can get a normal firmware. Okay, it's the future, Hans. So we'll try the red room now. Yep, and it stops. Perfect. Load Predator. So that will be load on Not, oh there, what am I doing? Okay, it's Jiffydos, I should be able to press like F1 I think. Yeah, there you go. I think I hit something, I got a nasty... and then I go to Predator I think, and then I can hit F3 maybe? Like this? Not sure, yeah, let's try that. Let's see if it's fast. Keep in mind, this disk is written like 30 years ago, so might not work, but it didn't make an error. So let's try run. Holy smokes. Oh my god. Look, there's a GRL turbo tape. Look! Wow, so this is cool. Hit space, see what happens. Probably decrunching or something. Predator. Alright, so let's try and switch the kernel to Dato, or this is Exos actually. Yeah, that's Exos. I think this one isn't so fast, but we can try. Yeah, F7. Then I think it's F6. Right. That seems to be working too. That was quite fast also. So now keep in mind this drive is not running Jiffydos anymore, so that's weird actually. I thought it would be slower then. But anyway, we have a kernel switcher going on there, so it would be fun if you could actually check this working. Keep in mind that if you don't have Jiffydos, the speed is incredibly slow. So let's try and go to Cyan. There goes the Cyan. We're in Datal. Datal isn't actually particularly slow in any way, so we will try anyway. Oh, just give me a moment so I can figure out how to read the error channel. Actually, I have some books up here. I can try and see if I can find the error channel. I think I have to read the VIC 1541. So in here somewhere we should find the error channel. See, loading prepackaged software, save load. There, reading the error channel, number 18. Yeah, so let me just type that. Alright, that took me a while, but I didn't read it properly. I had, there is a simple basic input routine here. So without DOS support program, there is no way to read the disk error channel without the program. So that's what I did now. That's why I had the error at the beginning there. But when I put it in basic, you can see. What's so important about this? We have Jiffydos here, right? But that's the C64. What's in the drive? Look, Jiffydos. That's what's coming back from the drive. You can try it again with using .tel. So let's just get to Cyan there, see what happens. Let's try the same thing again. It's very slow, so I have to type it in manually. Nice one! Look, we have CBM DOS. So that's working. Now let's try the one that where the drive is just running and running and running. I think that won't work. Run it. Now it's having problems. So something is wrong with the first kernel. That's a bit sad because I wanted to show you how slow that was. So maybe I should time it. Get to Jiffydos. load the directory. Try loading here. If you ask me, that was pretty fast actually. So now I'm going to try the two other rooms, so which doesn't require fast. So let's try Exos. See. If you ask me, that was actually quite faster. Might not work as fast for other things though, so I don't know. I thought Jiffydos was the fastest. But yeah, it certainly is on the ST2 IC, so. Okay, yeah, so that's it. Now we have Jiffydos on one room, and for good sports we're going to look at the load times of data. There you go. The data was a bit slower. There we go. See if we actually can start the game. Oh, it keeps loading. That's interesting. Right, so that's okay, that's interesting. So it was loading after the basic. So let's get back to Jiffydos and see how fast that is. So I'm just gonna go to Jiffydos, load the directory, then load this one, then cocaine, of course, we need cocaine. Then I'm going to press space, so we will time it in post-production. Let's see. Start it again. The thing is that they brag about it should speed up everything, right? So let's see how long this takes. That wasn't long at all, so I'm not sure if that's better or not. So, but there you go, Predator. Okay guys, so thank you very much for watching, and it was a fun project. I haven't done much projects in a while. So you can see all the mess. This is the C64 250-407 replica, KiCad replica. It has the arms in. Would be cool to put it in here to have some music. Yeah, so we'll continue to have fun projects in the future. And it's summertime, now just relaxing. That's why I'm actually doing this, but I was called back to work, so that was a bit boring. And but I really hope to get back to you again and produce more videos as time goes by. As you may know, I've told you before, I'm going to move. And that's why I have such a cramped space here right now, because things are everywhere. And when I move, it will be really great space. So thank you very much for watching. I really appreciate all the comments and all the interaction as usual.